Chemical equations is a way for us to read the reaction that is taking place. We use symbols and arrows and different mathematical signs to help us understand in a visual format what reaction, what transformation is occurring. Chemical equations are made up of formulas and symbols to represent the reaction that is taking place. There's a lot of information we can glean or interpret from the written chemical equation. First, big picture. We can identify what are called reactants. So that is what we are starting with. And then products. What was formed after the transformation of the chemical reaction. Then, diving in a little bit deeper, we've got, and I'm just going to read this from left to right, we have got these larger numbers in front of these chemical compounds. These are called coefficients. Coefficients help us balance the atoms on the reactants and the product side, because we have to make sure that we maintain the law of conservation of mass and matter. So we can't just have atoms disappear or atoms appear. So that's what the coefficients help us to do. Then we have the chemical formulas. And so these chemical formulas are going to be the balanced formulas based off the type of compound. So we've already gone through ionic and covalent naming and formula writing. Therefore, these are the representations based off those rules we have learned previously. The plus signs those just tell us that there's one or more of the compounds present. And then the arrow is what separates our reactants from our products. The arrow can mean to yield, to produce, to form, to make, whatever other synonym, English, you can use for those words. So we look for those words when we are reading this out loud. So if I was to read this, I'd say carbon monoxide reacts with iron 3 oxide to form iron and carbon dioxide, right? So I can take these words and put them into the chemical equation. Lastly, we have what are called the states of matter. So our states of matter follow the formula in which it is written, and these tell us the phase in which these reactions are going to occur in, right? So we have our state of matter, or our phase, and we can have the solid, the liquid, or the gas. You will, hopefully by the end of all of this, be able to predict and to determine the states of matter that occurs before and after a transformation. Breaking down the equation. As I mentioned previously, the coefficients balance the number of atoms on both sides of the arrow. This allows us to satisfy the law of conservation of matter or mass, which means matter can neither be created nor destroyed in any ordinary chemical reaction, which is what we're performing. Not extraordinary, we're not stars, we don't go supernova. So every atom that's a reactant has to end up on the product somehow. They can change their state of matter, but the number present has to be the same. Other symbols you need to be aware of, as we had mentioned previously. So our phase symbols are state of matter. Solid is an S. Liquid is an L, and I tend to do a cursive lowercase l. Some people see it like this, but that looks like a 1 to me. Up to you. Gas, aqueous. Now aqueous is a substance that gets dissolved in water so that it can react. We can use water to allow ionic compounds to become ions, because ionic compounds only react in their ion form. They cannot react in their solid state. or we use it to dilute a substance to make it not as strong or as concentrated. Heat, sometimes heat needs to be present to kickstart a reaction, or it's being given off as a product as well. We use a triangle to represent heat. And we have reactions that can go forward and backwards. So if we have a complete reaction, we use a forward arrow only. If it is a reversible reaction, we use 2 half arrows. And so we would tell you which ones we would use, but you just need to be able to recognize them at this point.